Next, I'd like to go over some examples to illustrate how we use these concepts from section 11.3. These are from the textbook. One of them is about weather conditions on successive days. It says, in November, the rain in a certain area tends to fall in storms of several days' duration. The unconditional probability of rain on any given day of the month is 0.500, but the probability of rain on a day that follows a rainy day is 0.800, and the probability of rain on a day following a non-rainy day is 0.300. So now we are supposed to find the probabilities for the following events, given to 3 decimal places. Okay, so number 79 says rain, the probability of rain on 2 randomly selected consecutive days in November. So let's say 79. So a randomly selected day in November, the probability of having rain is 0.500. That's unconditional. And then followed by a rainy day, the probability is 0.0800. So the probability then would equal 0.400. For number 80, the probability of rain on 3 randomly selected consecutive days in November, so number 80, so the probability would be equal to 0.500. It's for any day, and then followed by 2 days of rain. The probability is 0.8 times 0.8, and that's equal to 0.320. Okay, for number 81, rain on November 1 and 2, but not on November 3, and then there's a comment, the October 31st weathers are known. So we're going to assume that this is an unconditional probability of rain, 0.500. Now for a rainy day, that probability is 0.800. And now for not rain, the probability of not rain is 1 minus the probability of rain. And since the probability of rain is 0.8, it's 1 minus 0.8, so that's equal to 0.2. So times 1 minus 0.800. And that product is equal to 0.080. So for number 82, we are supposed to find the probability of rain on the first 4 days of November, given that October 31st was clear all day. So here it's clear. So we know that the probability of rain following a clear day is 0.3. So 0.300, followed by days of rain is probability 0.800, 0.800 times 0.800, and then the product of all these numbers is 0.1536. So we round that up to 0.154. So that would be our final answer. So that would be our final answer. 0.154. Here's another example about letter choices. Suppose a bag contains the 3 letters of the word MOM. If you take one letter out at a time and line the letters up from left to right as you take each one out, what is the probability that the letters will spell out the word mom? Well, let's look at a sample space. And so we could have the result of M, M, O, or we could have the possibility of M, O, M, and the only other possibility is O, M, M. So that's our sample space. There's only one that makes it work, so that probability is equal to 1 divided by 3. Here's a problem about coin choices. There are 5 counterfeit coins that are mixed with 9 authentic coins. If 2 coins are drawn at random, find the probability that 1 coin is authentic and 1 is counterfeit. Okay, so when you think about that, what is the probability? Well, when we begin, there are 5 counterfeit coins out of a total of 9 plus 5 is 14. And then there are 9 counterfeit coins, but now there are only 13 left for the second selection. It could also be the other way around. We could start out with 9 counterfeit out of 14, and then we have a choice of 9 authentic out of 14, followed by 5 counterfeit out of now 13. So it would be 45 divided by 182 plus 45 divided by 182. So it would be 90 divided by 182. And we can reduce that fraction to 45 divided by 91. So that's our final answer for this problem. The last one I want to do for you is the one about dice rolled. If 3 fair standard dice are tossed, what is the probability that the results will be 3 consecutive integers? Okay, so we want to think about the sample space first. The sample space for 3 dice is the first dice has 6 sides, the second one has 6 sides, the third one has 6 sides, so there are 216 possibilities for our sample space. Now, when we talk about our events E that are favorable for consecutive integers, let's think about consecutive integers. There's 1, 2, and 3. There's 2, 3, and 4. And there's 3, 4, and 5. And 4, 5, and 6. Okay? But each of these can be arranged in 6 ways. As you can see, I'm just going to do the first one for you. You can do the others yourself. So it would be 1, 3, 2. It could be 2, 3, 1, and 2, 1, 3, and 3, 2, 1, and 3, 1, 2. So in other words, 3 factorial. And the same is true for all the others. There's 6 ways to arrange 3 numbers. So in other words, there are 24 ways that this can happen. 24. So then our probability for the desired event of 3 consecutive numbers, the probability of 3 consecutive numbers, integers, consecutive integers, will then be 24 divided by 216, and that is 1 divided by 9. What's a little bit tricky about this problem is that the way the dice are arranged here, so it almost seems like you got to have them in this order. But obviously, when you roll 3 dice, they don't line up. They're scattered. So in other words, this could be 3, 2, and 4, or 4, 2, and 3, and so on. So in other words, that's why each one has 6 possibilities. And then 6 times 4 is 24. So that's why the probability of 3 consecutive integers is 24 divided by 216, or 1 divided by 9. Now, let me just conclude by saying that the key to solving all of these problems is to do lots of them. The more problems you solve of this type, the easier it will be for you. And so it'll take some focus, it'll take some time. So if you want to master these things, these word problems, you can. But again, you probably need to spend a little extra time on these things and give it some thought. But I know that with the right focus, you have what it takes to do it.